what is Docker? One way to see it is that Docker is a lightweight virtual machine. And lightweight in what way? So if we have a comparison of the stacks of a Docker machine and of a normal virtual machine. So here we have a hypervisor, here we have something called a Docker engine. But here we have a guest operating system, and here we have nothing. So that is really the main difference. That the hosts, I'll show you the next slide instead. So if I'm running in a virtual machine, I'll show a process tree which only shows the virtual machine on the host machine. It doesn't show me anything else, any other processes, because it doesn't know anything about those processes, because they're executing inside the virtual machine. But if I do the same thing on a machine that is running on the Docker engine, all the processes are visible to the host. So that means I can interact with these, with kill, PS, etc. But it's not recommended to do that. You're supposed to interact with Docker through the Docker command line, or the REST interface is also possible. So another thing that's different between virtual machines and Docker is that virtual machines are a lot heavier. They weigh in at about 1 gigabyte and move upwards. And the smallest Docker image is 0 bytes. It's a scratch image and it doesn't do anything, so it's quite useless. But there's a distribution called BusyBox that you probably have heard of, and it's a Linux distribution, and in a Docker version it's 2.5 megabytes. And if you're using Ubuntu, I think it's about 180 megabytes. And yeah, so it's quite small. The startup time for a virtual machine is typically 1 minute if it's really fast, 2 minutes if it's more normal, and it can get slower. A typical container starts in a second, or less than a second. And that is really, really good. In the integration scene is also, if you're integrating 2 virtual machines that are running on the same host, you have to integrate them as if they were running on different hosts. But if you're integrating 2 Docker containers, there's full support for sending in environment variables and linking the containers together and using volumes from one and the other. But that doesn't mean that virtual machines will go away, because virtual machines is the way that we work right now. So if we're using an Amazon server, we're using EC2 virtual machines all the time, and this is probably the way we will continue to work. But we will put a Docker engine inside those virtual machines. So we have our hypervisor or our virtual machine running with the guest operating system, but then we'll have the Docker engine on top of that. And if we really need a lot more speed or anything like that, we can just remove the whole guest operating system and the hypervisor. So another way to see Docker is like a change root on steroids. And change root is something that you use to lock in a part of the file system so that it cannot access anything else. So if this part here is locked in, that means that this is root right here. I cannot access etc or user or home because they're not even available to me. When I do ls, I get this part of the operating system or the file system. But it's on steroids in that it's not only the files that are logged in, it's also the networking and other parts. Okay, so why should we use Docker? And there are a number of reasons for using it. And one of them is better utilization. we used to buy servers. We don't do that anymore because it was costly, it took a long time. So now we moved on to virtual machines. And it's a lot easier. It takes me 5 minutes to spin up, or 2 minutes to spin up a new server in Amazon, and I can just do what I want. But the thing is that I'm still not using the entire server. If I get lucky and I have applications that are really successful, okay, then maybe I need 3 or 4 virtual machines that are working together. But most of the time, the applications are just running on idle. And this is where Docker comes in again, because then you can deploy multiple containers on the same virtual machine or hardware machine, and you say you have 20 applications running at the same time. If one of them starts to need its own server, okay, then you can just bring it outside. But you can just keep on running many applications that are on the same machine. And this is the #1 reason why you should use Docker, because it contains your dependencies. That's why we like to have every application on a separate machine, because if I install Postgres, say 9.4, and then someone else wants to use 9.3, it will be really painful to have them both running on the same machine. But with Docker you can do that. You can just have many many different versions of the same software running. And it doesn't take more than a few seconds to install ImageMagick, and that's a real plus in my opinion. So this is what Docker Incorporated calls the matrix of hell. We have development machines, we have QA servers, we have on-site customers, and we have a public cloud. We have a lot of different ways where we want to deploy our applications. And then we have a bunch of different applications. So what is supposed to be installed in all these? An operation doesn't want to have multiple versions of everything everywhere and have different environments for everything here. So the Docker solution just puts containers everywhere. So the unit of deployment is a Docker container. But Docker is also a contract, and it's the contract between development and operations. So we as developers, sometimes I'm more working in DevOps, but usually I'm a developer and I always want to use the next new shiny thing. Currently I'm trying out Go and maybe a little Rust, and nobody wants to put those in production because, okay, maybe Go is accepted because it comes from Google, but nobody deploys Rust at the moment. But operations, they want to have the same environments all the time. They don't want to change it, or they want to change it, but they want to change it at their pace. And this is where we can agree, because we want to have isolated dependencies, both of us. So Docker will put the love back between development and operations, because not only can we run whatever we want and prepare it for operations, they can help us out and create containers that will be an optimized Oracle database. Who knows how to optimize an Oracle database? I surely don't, but operations do, and they do it all the time. And they can just give me a container with an optimized version, which is really nice, that I can run on my development machine. So, and this is probably the reason why I really love Docker. It's because it's so fast. So instead of having to wait for 2 minutes to start up a new environment, I could just start up a new environment in a second, and then I can do some coding, and then decide, no, I didn't want to install all these things that I installed in the container. I just throw it away. So we can have, when we have something that is 100 times faster, it enables a lot of things. And one of those things is that, okay, I'll start up a new container. I'll try to install a bunch of new things. And then I don't even have to uninstall them. I just have to stop the container and then throw it away, and everything is just gone. So I don't have to clean up anything, and I don't have to worry about things being saved somewhere where it can interfere with the rest of my system. In testing, it's really cool also, because then you can have, say, a database volume with integration test data that you just store in a Docker container, and then you just give that to the developers and they can run the integration test with the same data on their machine. If you use it on a continuous integration machine, you just take the same container, run everything, the test, and it writes to the database and it changes everything, and then it just stops the container and everything just goes away. The same thing is if you want to deploy a production environment. You use Nginx, for example, so you have one version and you want to deploy a new version. You deploy a container that is using the same backend data or the same data volume, and then you just switch your load balancer over to the new container and it just keeps on running without anything happening, and then you can kill the old container. It's really, really enabling. And yeah, I used to have a demo here where I just started a bunch of virtual machines, or actually a bunch of Docker containers, but I'll just skip it for now because that's basically what it is. It's not a problem to run many at the same time. So now I'm going to start to deep dive. First I'll go a little bit on an overview, and then after that I'll go into a bit more deep into the commands. So how does it work? It's a client-server system. So you have a Docker client. If it's running on the host, it's probably something like the CLI. Then it just talks to the Docker daemon through a Unix socket. And you could have clients running on other machines, and you can talk over TCP/IP. It doesn't matter; it works the same way. But it's the daemon that handles the containers, and all the containers are running on the host, and the host is just the real machine or the virtual machine. So here are the main Docker concepts. We have a Docker file. We have some images. We have a registry, and we have containers, and we have volumes, and everything again is just running on a host. And to create an image, you can use the Docker file. The Docker file is kind of like a recipe for building images. So that's one way. You do Docker build and you build an image. But you could also, and when you have an image, you can run it or you can create. Create means basically the same as run, but it means create it and don't start it. Run is create and then start it. And then when I have a running container or a stopped container, then I can commit it and commit it back to create a new image. And I can also tag images just to make them easier to find. And I can push and pull them from the registry. And then we have volumes, which is kind of outside of the loop here, because volumes is storage that is outside of the container. It can be in a different container, or it can be on the host. Usually it is on the host. So, images. Images are just a hierarchy of files. You can think of them almost like a tar archive. But they also have some metadata that will be used when you start the container. So they have a default command that is run. They have some environment variables that will be set. And they have some ports that will be exposed. But in its simplest form, it's just a hierarchy of files. And if you're thinking of something like an Ubuntu Linux distribution, then it's everything that's needed to run Ubuntu applications. So you have apt-get to install stuff, but you don't have the kernel. The kernel is running on the host. But all other files, all the binaries, all the library files, they are in the image. But just the basic ones. You don't need to have the full Ubuntu installation. You just get the minimal version. And images are a versioned or a layered file system. So you have, you can have here's the kernel running, you have a busybox, and then when you start up the image you have a writable container, and this is where the container is working. It writes things there, it doesn't change the image at all. And if you create an image from a Debian here, and then you add Emacs, you add Apache, like with the apt-get install Apache, apt-get install Emacs, then it creates new layers in the file system. So I could start this image right here. I could also start this image right here. But in this case, I started this image that had Apache on it too. And it automatically creates a new layer in the file system where all my changes and everything, all my log files will be written to this. So, commands for working with images. We have Docker images just gives me a list of images. Import will take a tar file and create an image from that. Docker build will build an image from with a Docker file as a recipe. And Docker commit will commit a container to an image. I'll show you that later. And Docker RMI means remove image, and history will show me the changes that has happened to a certain image. So if I want to see this layered file system, I can do that with Docker images-vis, and that shows all the layers of all the images on my system. Yes?
List of changes, is it just a simple list, or you can see, for example, IP who changed something in the container to track changes?
No, it's just the changes in the images. The IP address is when it's running. You don't get an IP address until you start the container. Yeah. So it's basically just file system changes, but it can also be if you set a different port or you set an environment variable. They can be set on the image that you're creating, because they will be used at runtime later on. And all these layers are merged together to get a running file system. So if you remove a file here, let's see, then it's just tagged as removed right here. And then when you merge everything together, it's not visible to the top layer that is running it. Here are some example sizes of images. So the scratch image here, this is the one that is the root of everything. So it's just an empty file system. It doesn't have anything on it. And that's where everyone starts to build new images. So it doesn't have any size. But if you're deploying a binary to a Docker image, then you can just copy the binary into this empty image. So the only thing that's in the image is this one file. The busybox, like I said before, is really small, 2.4 megabytes, and it still has 10,500 files, but most of them are symlinks to the same file. Debian Jessie is 122. It's a lot smaller than Ubuntu 14.04, but it's still not any large sizes we're talking about here. If compared to a virtual machine, they're really small. So to create new images, you use Docker commit on a container ID. You can use Docker import and have a tar file that you just import. or you use Docker build. And Docker build is the way that you normally do it. So here's an example of a session where we're starting up a Docker container, Debian Jessie, with a bash shell. I'll try to install a bunch of things. I'll apt-get update, apt-get install Postgres. That works fine. I try to install Node. It doesn't work properly because I get something else. I thought I was getting Node.js, but it didn't work. So finally I gave up and I just curled to get IO.js and install that instead, unpacked it, and then finally I exit down here. I'll get the ID of the container, which is still available. It's not running anymore. It's a stopped container, but I can get the ID, and then I just commit it, and I call it Postgres IO.js. So then now I have created an image with Postgres and IO.js on it. But it's kind of sloppy because I made a few mistakes up here, so I don't really know what's installed. Maybe I installed something that shouldn't have been there. So instead of using that image and committing it, and I'll just create a Docker file instead, and I'll say, okay, I want to start from Debian Jessie. I want to run get update, install Postgres, and now I know what I want to install because I can run this over and over again until I'm happy with it. And then finally, I'll just Docker build it, and I'll tag it with this name here, Postgres with IO.js. And then I start from the current directory. And the cool thing about this is I can do it over and over again, and I can automate it, and it's really nice. But every command here will create a layer in the file system, which is by design, because if I run this command update and then install Postgres, and then I do something more, and then I want to, then this last one right here, then I change my mind. I don't want to install it into user local. I want to install it into user instead. Just a minute. And so if I change this command right here to install into user instead of user local, then everything here does not need to be rerun again. So when I build it the next time, everything here is cached because these images have been created before. So the only thing I have to do is this copy operation, which takes no time at all. And all the operations that are slow and that don't need to change very often, I put them higher up in the Docker file. Yeah?
Is there any way to amend the commit instead of creating a new one? Like, for instance, if you want to actually update, you download a lot of files that you don't want afterwards.
Yeah.
And what I would do, like to do, is actually update and get installed PostgreSQL, and then remove all the temp files.
Yeah.
And after that, I want to commit. Is there any way to do that without
creating images?
Without creating images between.
Yes.
And without using double ampersands.
No.
Okay.
Or yes and no. So the double ampersands, that's the solution to your problem, because then everything here is run as one command instead, so it only creates one layer. And if I remove everything that I don't need as the last step, okay, that's fine. Then it's not in the image in any layer. But I can also export everything. So if I really want to flatten the image, I can export the image to a tar archive, and then I can import it again, and then I get an one level image. But then I lose out on the versioning part of the, so I don't get the speed. So for development, I would definitely prefer to have a lot of layers. When I go into production, maybe I try to flatten it a bit more. Okay. So here's a more realistic Docker file. This is from the maintainers of Nginx. So this is the official Nginx image, and here we have the maintainers. That's just information. run is the commands that you saw before, and here we have something else. So we have an environment. So I declare an environment variable called nginx version, and yeah, it just gets a number. Then I run a command again, and then I run a couple of more commands. And here we have a volume, which so in nginx you can cache files, and if you want to start the container over again, you possibly want to reuse the cache, and you can do that because the volumes it's working outside the container. So if I kill the container and stop it or remove it, then I start it up again with the same cache files, everything will still be cached. I expose a couple of ports, 80 and 443, and this is the default command that will be run if I don't tell Docker to run anything else. So here are the commands that are available inside a Docker file, and they're available in two modes, basically: in run mode when you run the container, and in build mode when you build the new image. So from tells you what image you want to base your image on. Maintainer is just meta information about who's maintaining the image. Copy copies files recursively. Add does the same thing as copy, but with some extra bells and whistles. You can automatically unpack tar files, and you can give it a URL instead. Run lets you run any command inside the container, and on build is for developing containers that you base your image on. So if for example the nginx team wanted to create a container that you use as a base image, they would probably add on build where you copy your configuration files into the container. So then you base your image, and then you copy. You don't have to write anything in it because the commands that they expect you to use is written with on build. So in on build you can use run, you can use add, you can use copy, because these commands will be run in the container or in the image extending their image. It's just a nice optimization. You could just write them yourself. Docker ignore tells the Docker build engine to not move the files that are ignored into the container when you're building it. So this is the typical file that you put there is .git, because you don't want to copy your entire repository into the container because it's not necessary. It's not what you want there. Working directory tells what working directory you want. User, what user you want to run as. And they work both in build mode and in when you actually run the container. So, and in run mode we have command, which is the default command that you want to run if you don't give Docker anything else on the command line. Environment, setting environment variables. Expose exposes ports from inside the container, but they are not exposed unless you tell it to expose them on the command line. Volume will tell you, yeah, I'll go through that later on. An entry point is an additional way to write a command, but it's not so easy to override it as command is. When you do docker run my image and then you write a command right after that, then it won't. If you have an entry point that says, okay, maybe I want to run Java as my default command, and I only want to let the user give me options to Java. So then I'll tell my image to have Java as an entry point, and then when I run my image call, say, my Java image, and then I'll give it, I don't know, a class file or a --jar equals something, apache.jar. Then only the options will be changed. So, yeah, it's details, but it's nice to know about it. Okay, so that was images. Now we move on to containers. Containers are running instances of images, or they can be stopped and they can be restarted. It's like a process. And like I said before, they're running in the top layer here. And this is by default a writable container, but it doesn't have to be a writable container. You can tell, since the latest version, 1.5, you can tell Docker that you want it to be a read-only layer. And then anything that the image or the container wants to write to file, it has to write to a volume. So you have to provide the volume for it, otherwise you will get an error. And here's a bunch of commands. I'll just go through them quick. Creates a new container but doesn't run it. Run creates it and runs it. Stop stops it. Start will start it again. With the options that you gave run, you can't give any additional options when you restart a container. Restart is the same. You stop it and then you start it again. Removes the container or deletes the container. Kill sends a sig kill to the container. So if it doesn't stop fast enough for you when you give it stop, you can probably just send it kill and it will die quicker. If you start in a detached mode, which is kind of like a background process, then you can attach to it again with docker attach. Docker wait is usually used for scripting if you want to wait for a container to exit before you do something to it. And then docker exec or execute will allow you to execute commands inside an already running container, which can be nice, especially for debugging. So here's an example of how to run a container in interactive mode. -I tells me I want to run it in interactive, so I want to be able to send standard into the container, and TTY that it will respond properly to signals, and also behave as if there is a TTY attached. So if I send it Control-C, it will stop. If I give it -T. And -rm means that I will remove the container. Once it's stopped, it will automatically be removed. I don't have to do that. I can remove it manually after if I want to be able to go in and inspect it. So here, if I use docker run -d and then an image, I'll run in detached mode. So that means I can write another command right after that. So it's similar to a background process. I can also give my container a name, which will allow me to refer to it by this name instead of the ID that I'm given normally. I can give it environment variables with -n and -e. They are just synonyms. An env file will allow me to just send a standard environment file into it, and all the environment variables will be set. And then my SQL here is just the image. If I want to interact with it through ports or through networking, I need to publish it. And then I can use the -p option. And in this case, I publish the port that's running inside the container, which is 80, on my host, which is, and I chose 8080 here instead. And here I have exposed the ports 80 and 443, but I really don't have to do that, because the run command will just override anything that is said inside the container. I could also add an interface in front of this, because maybe I don't want it to be available to the internet, so I just want to expose it on the local host and nobody else can access it if I use the localhost interface. And then finally I can also use just -p. And if this is a capital P, and the difference with capital P is that it will expose all the ports that are declared inside the container. And it will expose them on a random port. So it's something like 46,723, and the other one will get something else. But you can inspect or you can just check what the process says it is mapped to. And then you can access it through those ports. Another way to get to access the ports of a container is through link. And so here I start a database with the name DB, and then I start another container here, Docker run, and it should actually say DB here because it's referring to a name, this container here, DB, and this is the name that will be used inside the container. So my application here will have access to a host. etc hosts is updated with this name. So if I access DB, what is it, 3107 or something like that? It's the default port. I don't know, something like that, or 3306. Yeah, whatever. But I can access that. It also sets a bunch of variables that tells what ports are exposed. But I usually just use the host name and then colon the port name to access it. Okay. It's also possible to set limits on the container. So I can set how much memory it is allowed to use, and if it uses more than that, it just won't start or it will be killed by Docker. You could also tell it how many shares of the CPU it should get. So in this case, I'll give it 512 instead of out of 124, which tells it, okay, it should get half the shares that a container running with all 1024 shares will get. So it will just limit how much access it gets to the CPU. And then the last way to limit the Docker container is through what user it gets access to. So this Nginx server will not be allowed to run as root, which is the default otherwise. So if you start a container, it will usually be started as root, and then it can change user if it wants to. But if I don't want it to be allowed to do that, I can tell it here to use www. And then Docker exec, I talked about that before. If I want to get into an already running container or a stopped container, I can run Docker exec and then the name of the container or the ID of the container, and then I'll get a shell, and then I can do something in it to check log files or whatever I want. Okay, so volumes. So volumes provides, yes? You can have a user that's specific to the Docker container.
Right, but
yep.
Can I share users with the host operating system as well? Or?
I'm not really sure. Yeah, possibly you can, but I'm not sure. If you get root in the container, possibly you can. There are some things that are not totally secure that I'll talk about a little bit later. But yes. Right. So they provide persistent storage outside the container, and that is typically the host, but it doesn't have to be. So and this also means that containers are not affected by the layered file system or the union file system because they're outside of it. So if I do a lot of things inside the container and then I commit it, and some of those changes that I did was actually on a volume, then they are not committed in the image. Kind of obvious, but it's easy to make the mistakes. Anyway. So here's how you run. Docker run, and then I'll give it var log. And that tells me that inside the container, var log is outside the file system. It's not part of it's a volume that's stored outside the file system. And since I haven't given it a path here, it will by default come inside the directory called varlib docker volumes and then some arbitrary number that's a SHA of that the container creates. But I can also give it one of my directories on the file system and tell it, okay, so now I want the container to store all its log files inside my temp directory on the host. And then the third way to share containers is from one container to another. So by using volumes from, I can say here, okay, I have an nginx container running with varlog nginx. Then I have another container running which does some statistics that it will show on the web or just display the statistics on the web, which is running on var www. And then I have a worker that uses the volumes from the nginx server, and it uses the volumes from the stats container, and it does some manipulation to the log files, and it will create some statistic images which it will store in var www on itself, and then finally it will be accessed when inside this container. And this one, the host file system is not involved at all in the moving of these files. Okay, so Docker Hub. Docker Hub is the official image registry. And it's a repository where you can store public images. You can store as many as you like. And you can also store private images. And you can store one for free or as many as you like if you pay for it. A new feature that they have is called official repositories, which is very nice because a while ago you could go in and find, say, 200 different nginx images and you didn't know which one you were supposed to use. But now there's an official tag which tells you that the maintainers have somehow been involved. Sometimes, in the case of nginx, for example, the maintainers also maintain the Docker images. But in the WordPress case, it's someone who is outside the WordPress project, but they maintain the image officially for the WordPress code project. Another nice feature is automatic builds. So if you have a Bitbucket or a Docker repository, or sorry, GitHub repository, then you can just point to it from Docker Hub and say that, okay, whenever someone commits something to my Git repository, I want you to create a new image based on the Docker file that's in that repository. Very nice. If you don't want to use the automatic feature, you can use Docker pull and Docker push to get repositories or get images from Docker Hub, or to push it to Docker Hub. And if you push it to Docker Hub, you usually have to namespace it with your name. So it's similar to what you do on GitHub. You have all your repositories under your name or under an organization or whatever. Same model. It's also possible to have your own registries, and if Docker publishes an open source repository where they have a Docker registry. We've tried to use it and we were not really happy about it because the performance wasn't good, and perhaps it has changed, but we ended up using Docker Hub instead. There are other providers of repositories. Quay was something that was acquired by CoreOS. And they provide both, maybe both private and public repositories. Tutum, the same thing, another company that's involved in hosting Docker. And Google Cloud Platform also has a container registry that you can use. So here we're back to that interaction image again, and perhaps it makes a little bit more sense now. So some commands also for inspecting running containers and images. So we have Docker PS, which is just shows you the running containers. Inspect gives you information about a single container. Logs will get you the logs from a container. Events will get you changes that is happening to Docker, so you can see a new container has been deployed, or listen to things that happen and react to them. Port is a convenience command for inspecting an image and getting the port out from it. Top will show you all the processes running inside a container, because it doesn't have to be a single process. If you run something, it can be a bunch of processes, but maybe you're only interested in one, but there's supporting processes for doing logging or something else. And diffs will show you all the files that are changed in the container from when it started to run, or from. And then since 1.5, you also have a stats command that you can send in, and then you get information about CPU, file system, etc., memory usage. And that's mostly used by monitoring tools, but it simplifies things. So Docker PS-all will list all all containers, both running and stopped containers. So here we have the images, the command that run them, and then they also get, if you don't give them a name. I gave this one a name, dbdata, and this one, some Mongo, but the other ones get a random name which is like an adjective combined with a scientist. So sometimes it turns out quite funny. So here, for example, we inspect Silly Bartik, and then we get information about that running container. And this is heavily truncated. It's about maybe, I don't know, 100, 200 lines here normally. But it contains the command, it contains the host name, the image that it was started from, the ID, network settings, volumes, etc. So some more tips and tricks. To get the ID of the last container, which is very useful if you're scripting and you want to do something with a container that was just started. You can do docker ps-l, and -l means the last container, and -q means quiet, so it only gives me the ID. Docker inspect takes an F for format, and inside this it takes a Google or a Go template language. I don't know, script, I guess, expression. So here I want to get the IP address of this container right here, and it will give me 172.17.0.11. So all containers will have their own internal IP. And this is also really useful for scripting. If I want to find out all the environment variables of a running container, I can do docker exec, and then I just give them the command environment, the normal Unix command. I could also do bash, and then I can go in and run the command inside there. But if I do it this way, I can get it and use it in a different script. A way to speed up your development cycle, so you don't have to rebuild the image every time you use it before you run it, is to use images. So here we have a Docker file, and you can see here on line 9 and 10 that I copy all the files in my current directory into server app. And the typical way to start this is to, okay, I build my new image, and then I run it with the run command. But I don't have to, once I've built it once and I have everything inside it that I need to, maybe dependencies or yeah, stuff like that, then I don't have to do Docker build every time again, because even though it's fast, it takes a little bit of time. So then in this case, I just do the same run command, but then I mount the current directory in right here. So this is exactly the same path that I was using to copy the files into the image. But in this case, I don't have to copy them into the image every time. But if I want to build the image later for production, then I need to build it and deploy it somewhere else. This only works on the current machine. So, security. You may have heard something or read something about that it's not safe to use Docker, and it's true, depending on your use case. Because image signatures are not properly verified. So if you download an image from Docker Hub and you try to verify, or then it's automatically verified since the latest version, but that's only an experimental features. They're not guaranteeing that it's conforming to the SHA that they have published also. So, yeah, it may be a problem. And also, if you have root inside a container, so this is one of the reasons why you may want to start your container as something else than root. Because then you can potentially get root outside on the host. So if you're running multiple containers from different customers, you shouldn't allow them to run as root. And the security remedies for this is, okay, you use trusted images. So you use images that you host in your own private repository that you have verified, and that you maybe the official images, and then you rebuild something on them. You just don't download anything from Docker Hub, because you don't know what someone has done with the images unless you verify them. And you avoid running containers as root if they don't need root. And if they do need root, then you should treat the container as if it had root on the host. So you shouldn't be running it with other people's containers. And usually this is not a problem, because you will just have your own virtual machine where you're running your containers. It is maybe a problem for a platform as a service or a container as a service provider. So, some container options. I'll start with drawbridge and LXD, because I don't know anything about them. I know that this comes from Microsoft, and this is their container experiment, or that they're working with. Everybody has realized that this is a good idea, so everyone is trying to create their own containers. And I don't know why Ubuntu is creating their own, but they are. But Microsoft needs to, because they have a totally different platform, and they can't run Docker in the way that it's running on a Linux container, because it reuses the kernel, and it can't be done. Rocket, on the other hand, Rocket is developed by CoreOS, and CoreOS is one of the biggest users of containers. It's yeah, I'll talk a little bit about CoreOS later on, but they decided somehow that because they want a new container specification, because they think that Docker is trying to do too much. Docker has moved from being a container specification into being something that yeah, becomes a clustering solution, and CoreOS is already a clustering solution. So this is interesting. But it's still in an alpha stage, so that's why the options is in quotes, because there are no options. It's, if you want to use containers, right now it's Docker you use. But perhaps in the future you can use something else. But it doesn't matter, because, okay, then you just switch to something else. The way you use it will be the same anyway, and the benefits you get will be the same anyway. So, a little bit about orchestration. And orchestration means clustering and joining containers together. So, the problem with this is that Docker containers are meant to be used as a single unit. So you have one Nginx server, you have one MySQL database container. Typically, if you're running a WordPress installation, you have an Nginx, you have a PHP, you have a MySQL as on the same. Everything is running on the same machine, but with containers, you're encouraged to split things up, because then you can upgrade the versions or by their own life cycle. So we have basically two use cases. We have to deploy a group of tasks to a single host, and you can already do this with links with Docker. But it can be, the experience can be made nicer. And then the second use case is to deploy a bunch of services dynamically into a cluster of hosts. And for this you need some form of service discovery to find out where the new containers come up and where they need to go. The first problem is solved with Docker Compose, and it used to be called Fig, but Docker bought the company called Orchard that developed Fig, and they renamed it to Docker Compose. And Docker Compose looks like this. So you have a YML file, a configuration file, and this is basically the options that you give to Docker run or Docker build. But they have put it all together into one file. So here we have one container web and one container Redis. And the web container links the Redis container. And the Redis container, it doesn't need anything else, because it's the Redis image is self-contained. So if you start it up, it will just start. But the web is my own application, so I need to build it first, and then I need to run a command, python app.py. I publish the port on 5000 on my host, and I want to mount my current directory to the code directory, and everything is put together. And when I run this with Docker Compose up, it just it starts up it brings down the Redis image, it starts up the web image, and it builds it and starts everything up together. And I could also start them up with -d, which means, they start up in the background, and then I can use Docker Compose, and it will only show me, Docker Compose PS will only show me the images that this Docker Compose YML file is managing. And I can also run commands for a single container. So if in this case I Docker Compose run web and environment, so I run a single command inside the web container, I can scale it to so I start up multiple web containers and multiple Redis containers, but I have to manage the load balancing and myself. So I have to write code for that. I don't get any load balancing for free with Docker Compose. So it has to handle that, there can be two Redises. What do I do then? And to get logs, I can get logs from all containers with Docker Compose logs, or I can get logs from just a single container. And there are a bunch of other commands too, but they're matching the commands that are in Docker. But it's a nice way to start up. And if you have something that you want to start up, say you want to run a Kafka cluster or something, then it's really nice, because then you can just download a Docker Compose YML that has information. We want to start a couple of zookeepers and maybe a couple of Kafka servers also. And everything is just started, so you just run Docker Compose up and you're ready to go. Nice. So hosting. There are a bunch of people that wants to get in on Docker. And I'm not going to talk too much about all of them because I don't know enough about all of them. So I'll talk a little bit about CoreOS and about Amazon. Docker also has some new tools. They have Docker Compose, like I showed you before, but they also have some alpha software called Machine and Swarm for doing clustering. But I haven't played with it, so I don't know how it works. So, CoreOS. CoreOS is not only a Linux distribution. It is a Linux distribution. But it uses Docker to manage its applications. It uses systemd, which is an init system, to manage its processes. It uses etcd to manage configuration across the cluster. And it uses Fleet as a cluster manager for running commands against the cluster. The CoreOS is a minimal Linux distribution, so it's only 114 megabytes RAM on boot. It doesn't have a package manager because everything is supposed to run as containers. Docker containers or Rocket containers, because they're the ones that are developing it. It has a really nice dual partition scheme, so if you want to deploy a new version of the CoreOS, it is deployed or downloaded to the passive partition, and then when the system is restarted, it starts up from the partition that has just been updated. And if something goes wrong, it can just roll back automatically. And they also provide managed version, so you don't really have to worry about it because they can just update it automatically. It uses systemd as its init system because it's a modern init system with a nice journaling system for logging. And it has something called socket activation, which means that you don't have to start up an application for it to be able to listen to a port. So you can listen to a port, say a port 567 or something, and then the service that needs that is listening to that port doesn't need to, because the systemd will be listening to that port, and once it gets a request, it will start up the process and hand over the running socket. It's something that's already supported in initd, if you're familiar with that. But one thing about socket activation is that it's not supported for Docker containers. It is, however, supported for Rocket containers. So that's another reason for them to start up with their own container specification. It's okay. So it's a distributed data key value store. Yeah, it's very nice to use. It uses the Raft consensus algorithm. So if you want to see how that's, Google it, because they have some really cool illustrations. If you just remove one host and it will re-elect a new leader and stuff like that. But I don't really care about that. I just want a database that I can interact with, that I know is available all the time. To run commands against etcd, you can use either curl or you could just use the command line here, etcd-ctl. So I can do set, and then I'll give it a key, which is a path, so it's similar to S3, I guess. But it's not meant for storing large file, it's meant to store small configuration files. And then I'll give it a value, and then I can give it also a time to live. And after 60 seconds, it will be gone. I can get the value, I can list all the values recursively, and this is a nice part here, you can also watch for changes to keys. And that's valuable if you're doing configuration. So if I'm listening for changes to new services coming up, I can just listen for the changes, and then I can reconfigure my load balancer to start using those services as they come up. And Fleet is the cluster manager, and it's built on top of systemd. and it uses etcd for configuration, and it's installed on every part or every host, core OS host, and yeah, you can interact with it through the CLI or through a REST API. And CoreOS is running in production on a lot of people are using it. They have hundreds of customers using clusters that are up to or more than 100 machines, and they seem to be happy with it. But it's not seamless. It's seamless to get things working together in the cluster to bring up Docker machines, but to get your services running inside the Docker machines talking to each other is not fixed out of the box. You have to do that yourself. So Amazon Web Services, of course, they are also in this game because they're the biggest cloud provider there is. And currently you can just use Beanstalk. It just works. Instead of deploying your Java application or your Node application or whatever you use, you can just deploy your Docker application into Beanstalk, which will give you load balancing and everything you need. But my problem with this is that it's slow. Maybe it's not a problem if you deploy your production servers because it doesn't matter. But if you have development servers and you want them to have a fast pace, then I think it's painful to wait for 2 minutes when I know that the Docker container can start in 1 second. So obviously Amazon also thinks so, because they're developing something called Elastic Container Service, and it's currently in preview 3, and it's working very nice, apart from some glitches. And one of the glitches is that it's only available in US East, I think. And that when I was using it, when I killed containers with Docker kill or Docker stop, it didn't really show up when I used the service interface. So there was a problem there. To interact with it, you can use the Amazon CLI tools. So create a cluster, run instances. That's just easy to run instances, by the way. And then you just use the standard ECS image, and it will automatically register itself with your cluster. You can register task definitions, which is yeah, I'll show you one later. You can run tasks, you can list tasks, you can do everything you need to do. Here is a container definition. It looks similar to what you use in Docker Compose, but it's not the same. And I don't know why it's not the same. It would have been nice if it was the same. But perhaps it will be, or perhaps Amazon is just, maybe they need something different than Docker Compose. So, final slide. Docker, okay, it fixes dependency hell, and that's really nice, especially if you're developing different environments, you have a lot of things on your machine. You can use exactly the same environment on your machine as in the production machine. The containers are really fast. They start in less than a second, and there are cluster solutions that you can use right now, but you have to do some work to use it. So that's it. If you have any questions, fire away.